by that point, I, by the way, have shifted to a different mission support area, so a different control room. It'll be in a different area here at JPL, but it's and the surface team will be there to sort of monitor whether or not we get a communication signal. But so that would be the next time we would hear from it is at that 12:30.
Okay, and if you would, just one other question. You had said that the entry seems to be picture perfect. Could you give us just a little bit of comparison with other Mars entries? Does this one seem to be more precise, about as precise as others? Have there been others that were way off and then suddenly were able to be brought back in?
I think this is about as good as there is. I haven't seen one better than this one. Richard?
No, I think it's exactly what you said. This spacecraft design, the way that this vehicle is designed to fly during cruise, is the same way as MER and Pathfinder before it, and because of that, they're very, very good as far as navigation. That we have a very good idea where they are, and so on all of those spacecraft, they did about the same as far as their ability to get it to the right spot. In this case, we have the challenge of not only getting it to the right spot, but also telling it where it is, which actually makes it even more of a challenge. And so that part of it, they're actually doing even better than what we've done in the past. So.
All right, we're going down the aisle here. Go ahead.
Hi, I'm Alan Boyle with NBC News. And I wondered if you could talk a little bit about the scenario where there are no signals received and how long that search is going to continue. I think with the Polar Lander experience that went on for a while. And then a happier thought would be having plans for MRO to take a picture of the landing site. Are there any plans to do that at a particular time?
Yeah, I guess I should talk about MPL since I remember it better than most. I think that the way we sort of look at it is that there are certainly very credible scenarios by which those Odyssey and MRO passes, in the first 18 hours might or might not happen, and so because of that, we definitely think that we can identify ways in which we would have to wait until the next morning, for example, to hear the MRO pass. The X-band, same thing, that if we, for example, had a problem with the radio, the UHF radio on the rover, it's not going to, we actually have two of them, but it's actually not going to switch over to the backup one on its own, that it would take, for several days, it would take a while to change over to the other radio. So because if, for example, we had a failure of the radio, we would certainly not hear anything from any of the orbiters. So because of that, there's a scenario in which you might say, well, we have to wait all the way until 5:30 the next night to hear from the separate system that does direct-to-Earth communications. And so those are all very credible, or certainly credible situations where we'd have to wait through that. Once we get past that first beep, from the X-band system, if we haven't heard from it in any of those communication paths, including that one, then I think that we would be definitely in the not as, in the more likely than not that we had a problem. And so it would take 24 hours, order of 24 hours to come to that conclusion. There are certainly scenarios that we can come up with, and we've got a lot of smart engineers who can think of, off-nominal paths that can get us to it taking longer than that. But frankly, I don't think they're very likely. And so I think once we get past that first day, we're definitely in the low probability category. MRO, so yeah, you asked, are we going to try to take a picture? When will we get it back? They are going to try to send it back pretty quickly after landing. And so we hope that we will get it by the time the next morning comes around. We'll have that picture, but it depends on if they got it and how long it will take them to process it. But we're pushing to try to get it that next morning.
And that would be a picture of the landing site post-landing?
No, that's a picture as it's going down.
Right. Is there any?
Then there is a plan to actually take another picture from MRO of the vehicle, the rover, on the surface the next day. So like 24 hours later, there'll be an attempt to take that picture. So.
Okay, we're going to come to the very front of the room here.
Thanks. John Panamos, BBC News. Just remembering back to Phoenix, I think there was one person in the control room who was tasked with calling out the milestones. Will we have something similar this time so that we know we can follow it?
Yes, we will. Steve, you can talking to the
Yeah, we will have someone in the control room. Alan Chen is his name, and he'll be narrating the sequence as we go through it. He'll be calling out the tones that we'll be receiving from the spacecraft as well as the UHF data. So he'll be the voice of mission control that you'll hear in the feed. Alan Chen. Chen, yes.
Let's see here. Let me see where the mics are. Okay, let's go here, and then we'll go back on the aisles.
Jackie Goddard for the Times of London. First, Steve Sell. I apologise if I haven't grasped this, but I just want to be clear. This all-important beep that tells us that it's down and landed, what form does that take? What do you see? Do you see a line of code? I think you said you don't actually hear a ping, and it's not presumably just saying, I'm here. What do you actually see that we're wanting to...
You asked a very technical question, but basically it's a line of code. We call them EVRs. That basically it's just almost, you can almost think of it as a text message kind of thing. They're very short and they have a little bit of information. So the touchdown EVR will contain everything from a couple of numbers that tell us how fast it touched down to where it actually thinks it touched down. And so we'll get that information, and it'll appear on our screens. It'll also you'll see that indication on the displays that are available as part of the feed.
Do you happen to know what EDR stands for?
Oh, event record. Event record. Sorry, you can't take the engineer out of the the acronym out of the engineer. Yeah, right.
EVR.
Yeah, EV event R record. Yeah.
Okay, next.
Steve, can I just follow up with Scott Gold with the Los Angeles Times? So it's essentially an either-or situation as far as when you'll receive confirmation that you're on the ground. In other words, if you have Odyssey coverage the first time, you'll receive that at roughly 10:31, and we'll see you high-fiving each other, and we'll know at that point something. If you don't have Odyssey coverage, then it's an either-or scenario, and you won't know anything for sure for another 2 hours, one way or the other. Is that?
Yeah, that if we don't have Odyssey for whatever reason at touchdown, then yes, it would be several hours till we could know anything additional.
Okay. And what might we be continuing the effort to please our editors on a very tight deadline? What what might we listen for from Alan Chen to when he offers confirmation to you that something good has been received at 10:31? What should, since we aren't in the room, what should we listen for that would give us an indication that things are progressing as expected?
They will be playing the audio. Alan's audio will be played over, whatever feeds that you happen to be watching. So you'll hear it the same time we hear it, and he'll say that the rover's been, or that we've received the signal that the rover has touched down on the surface.
Thank you.
Okay, let me go. I'm trying to get people who haven't had an opportunity yet. So we have one in the back there.
Hi, Steve Gorman with Reuters. My editors are also interested in they want to know when this thing hits the atmosphere at 13,000 miles an hour, I think you're going to be getting a beep that alerts you that that's happened. Is that right?
Yeah, that's right. The tones, kind of some major events that we'll get by tone only. We'll get cruise stage separation. Let me give you some Earth receive times on these. So around 10:14 or so, 10:14, you'll receive cruise stage separation tone for that. We should get an entry tone at around 10:24, about 10 minutes later. And then, like I said, there are a couple more along the way that we use to tell how far along the spacecraft has gotten during entry, descent, and landing. So we send out some tones when we start the turns, the bank reversals, and when we are deploying the parachute and things like that. But we, like I said in my at the beginning, the Earth will set from view of the spacecraft at some point while we're on the parachute. So at some point, about a minute or so after the parachute deployed, we will no longer be able to receive those tones, and we'll be relying on the data relay through Odyssey for the remainder of landing.
Okay, and can I just so if for some reason there's not a tone when the thing you don't get the Odyssey's not available when the thing actually lands, and so you don't know whether it's landed or not. I believe you guys said the next opportunity for you to get some data would be at 5:30 when there's an MRO overpass, 5:30 a.m. our time.
No, it's so yeah. So let's go through it again here. It's a little confusing because Odyssey is there and it's sending us data back in the bent pipe mode where he was saying you get the data essentially in real time. In addition to that, though, MRO is flying over at the same time and it's recording all the data. Okay. And so during the middle of the night, that data, after the Odyssey pass, actually, that data will get transmitted back to the Earth, and we will start processing it here on the ground to see whether or not MRO recorded the
anything that Odyssey missed,
or if Odyssey missed the whole thing, MRO certainly could have been recording it. We just won't know until that data comes here to the ground and we process it and we go through and do the signal processing we need to do.
And how long will it take before you receive the MRO, the pre-recorded, if you will?
I think it gets to the ground in about an hour and a half after landing, and then it will take us somewhere between an hour to determine if there was a signal there, and then about 4 hours to get the telemetry data out of it that tells us what the spacecraft was doing during.
But Odyssey wouldn't have another crack at it for another 12 hours or something.
Right. So it's sort of there's an interleave set of things. Odyssey is doing its own thing. Odyssey has the pass that's at 10:30, and then another one at 12:30. At night, right?
12:30 a.m.
12:30 a.m.
2 hours after landing.
That's right.
So is it possible that Odyssey might pick up something on its second pass at 12:30 that you still wouldn't have found out about because MRO still hasn't transmitted back?
That's right. Exactly. So there's various scenarios by which we might find out either from an Odyssey overflight that occurs 2 hours later, or when we go back and process the MRO data, or even when we look at the the Mars Express data, which kind of shows up in that time frame as well. So all throughout that night, we're getting various pieces of information, and in all of these cases, each of the spacecraft is retransmitting it a couple times, because we could also lose the data, as it's transmitting it. I mean, the orbiters sometimes have data dropouts where the data doesn't all come down, and so they're going to send it multiple times just to make sure we got all the information here on the Earth. Right. The next time the rover will try to communicate to us after that 12:30 opportunity is the next morning at like 11:30 a.m. here. Where it will again try to communicate through MRO and Odyssey in a new time that it will try to communicate.
Through the bent pipe, or is that direct?
In the case of Odyssey, yes. In the case of MRO, no. It will record it and send it back.
I mean, the rover, you said, will next try to communicate directly to Earth?
No, to the orbiters.
To the orbiters. Okay.
Yeah, its first time that it will try to communicate directly to the Earth will be at 5:30 on Monday afternoon. So almost 18 hours or whatever after landing.
Thank you.
All right. Well, let me just clarify one thing. Well, we'll be doing commentary during landing, of course, and right after landing, we will switch to the surface mission support area for that 12:30 Odyssey pass. So you will be able to see both that night, the initial one at landing and then the one a couple hours later. And let me see if there's someone else in the room who has not been able to ask a question yet, and then we will invite NASA social participants if you'd like to ask a question. So we'll go right here on the aisle. Thanks.
Hi, this is Mike Wall from Space.com, and I wanted to ask a question, actually, of the guy who just walked off the stage and coughed ash window. This is about Mars weather, dust storms, and such. I mean, you're saying that it's never going to be a serious concern because you've sort of designed this craft to sort of weather whatever dust storm that could be thrown at it. I mean, have you ever seen a dust storm on Mars that is strong enough, big enough, conceivably, to actually imperil the spacecraft, or is it always just kind of an annoyance where it might push it off course a little bit?
Yeah, that's the analysis we did with the past years of data. The guy I mentioned, Bruce Cantor at Mail and Space Science, has spent years counting every dust storm, learning how they behave, figuring out how they evolve over time, how the winds blow associated with those dust storms. And at this season, we realized that if we were to land, right down the middle of a dust storm, we could actually get winds that could, fairly severely affect the ability to time some of the events when some of these critical events happen, because the spacecraft is sensing the conditions in real time. So there could be certain cases where